This video is going to cover the solutions for the second semester final, and we're going to start with problem 12 and work to the end. But I'm not going to cover all the problems. I'll cover those that I think are probably the most difficult. Briefly about number 12, when you're trying to find the sides of the angles of the triangle, the sides and angles, you'll need to draw out that triangle. And that's why in the solution, I show the triangle drawn. But your first step is to find the angles and then find the side. When I'm trying to find the angles, I can use the law of sines and isolate the particular angle I'm looking for, which initially is going to be sine of B, because I've already got the angle A. And when I set that up, I can put in all my information. The only thing unknown is sine of B. And when I get to the sine of B isolated, then I'm going to get a number. Now that's just the ratio that sine of B equals. In other words, this is opposite over hypotenuse. But now I have to find angle B, so I take sine inverse of that number. And when I do on my calculator in degree mode, I get that answer. Now I know that once I've got angle B up here, and I've already got this angle A, all three angles add up to 180. So I'll add 36 plus this angle right here. And when I add those two and subtract from 180, I get my answer for angle C. So now we have angle B, we have angle C. Now we're ready to find the unknown side C. And in order to do that, I can use the law of sines again. I'll put in everything I do know. The one thing I don't know is C. I do know sine of C now because I know what the angle is for C. I know sine of A. I know what small a is because that's given right in the problem as 8. And so I put all the numbers in, and when I do, I isolate C in order to get its value. Now, if you got stuck on that isolation of C, the easy way is probably to flip everything upside down. So I have A over sine of A and C over sine of C, and then all I need to do is isolate small c, move big sine of C over to this side, and then I'll end up with small c side being sine of C times A over sine of A. Plug in the numbers, you get your answer. Don't forget your units. For number 13, very briefly, the key to this is to use the area formula for any triangle that is not a right triangle. And we have a constant value S, and then we have sides A and B and C, which are given. I have to find S first. That's my first step. There's the formula. I plug in my sides, divide by 2, and I get my answer for S. Then I'm going to use S in this formula here and here and here and here. And when I plug those in carefully with my calculator, I do the subtraction, the multiplication, and I get 19.81 centimeters squared. That should have been out to 3 decimals. Just make sure it's centimeters squared because you're talking about area. The big one, though, is number 14. And on 14, they want you to figure out the formula given the information in the problem, which was that the fifth term is equal to 90 and that the common difference is -3. So in coming up with a formula, I know the formula reads A sub n equals the first term plus n minus 1 times the common difference. Now, I constructed a table starting at 5 and 90, which was given. The fifth term is 90. N is the term number. A sub n is the actual term value. And so when I did that, if I'm talking about d equals -3, I'm talking about moving forward from 90. And I'm going to basically add a -3. But I'm going to go backwards to get all the way back to my a sub 1 term. And so I subtract 3, subtract 3, subtract 3, subtract 3, or rather add 3 all the way. I apologize. Add 3, add 3, add 3, and add 3. And that's going to take me to 202. And that right there is my a sub 1 term. If I wanted to go a step further, I could find a sub 0. But I don't need that. I can just plug a sub 1 in, which is 202. My nth term right here is this number, which is going to be just, leave it as n at -1. You don't need to put the 1 in. Just leave it as n minus 1 and put in your d value, which is -3. Now I distribute -3 times n. I get a -3n. -3 times -1 is a +3. And then I have 202 plus 3, and that will give me an ultimate answer of 205. And then you have the -3n goes right there. So you could leave your answer just like this. If you got it this far and didn't add those two, you need to take that extra step. By the way, how do we find a sub 5? Well, if it wasn't clear in the problem itself, you can write down a sub 5 is equal to a sub 0 plus negative 3n. Now, we've already found by going backwards, the 90 came from a sub 5, and I'd put in what the values were, 190 equals a sub 0, 5 times negative 3, and when I isolate, the only thing left unknown is a sub 0. So what I'm telling you is another way to find a sub 0 besides a table is you can plug in a sub 5, which is given, you can plug in the common difference, you can plug in n, and when you do, you'll get 205. But this stage right now, there is not necessary. A table will do that for you. Number 15 is pretty straightforward. It's just the sum of numbers. Remember, this is arithmetic, so it's n over 2, a1 plus the very last term. And then you've got to figure out what n is. It's always going to be the first and last subtracted, so you have 50. Remember, we're talking about all numbers between 51 and 100, and there are 50 numbers. So I have 50 over 2, and then I plug in a sub 1, I plug in a sub n, and then I end up with my answer. 17 is a pretty straightforward one. Remember, it's n over n minus r times r. All of those are factorials. And they give you the r right here at the 3. That's your r value. There's your n value. And you end up with 4 as your answer. Remember, this is a formula right here if you're trying to figure out what this last number is and what the first number represents. When we go to number 18, which gets into the second part of chapter, or the first part rather of chapter 11, the key to this is to try substitution first. In fact, on every one of these problems that don't go to infinity, this one, 19, those two there alone, you should be substituting in 0 as your first step. But I can't substitute in 0 without getting something undefined. And I can't do it here without getting something undefined. So for number 18, I'm going to have to use a conjugate because when I try to factor, there's nothing really to factor there. So I use the conjugate. Notice the minus 2 becomes a plus 2. I'm going to have to multiply these two out, stacking them with tic-tac-toe, and when I do, I get this value on top. When I multiply these out, and I'm going to have x times this whole value right here, then I'm going to get this value right here. Don't forget to write limit notation, and then I can begin to clean it up. As I look at that, I can plug in a 0 here and a 0 here, but I've still got a 2 left over. So this whole term goes to 0, but I'm left with 2 right there. And then if I put a 0 there, I'm left with 4 minus 4. And basically the x's are all I'm left with. These two cancel out. And so I have x on top, and then I have an x down below. And if I have an x on top and below, those two can basically drop out. And then I'm left with just this. Now, if I'm left with just this, I can either substitute, as I said, or now might be the time to substitute. I put in 0, and when I do, I get 0 plus 4. The square root of 4 is 2. 2 plus 2 is 4, and I have just a 1 on top. Now, that 1 on top is because x over x turned this whole thing into 1. It's not a 0 on top. You don't want to substitute too early. You want to get until you get to the simplified form. 19, the key to this one is to use your graphing calculator. So if you graph it, you'll find there's an open circle up here at 3. The key to this is to remember an open circle does not determine a limit. And so as I approach from the left, I am trying to get to 3. And as I approach from the right, I am also trying to get to 3. So they have a common shared yearning to get to 3. My answer is 3, even though there's nothing there. On number 20, we're going to infinity. Now that's where your n and m rules come into play. So on the numerator, I really got 6 times x to the 0. And so the denominator is dominant. And because the numerator is less than the denominator, my answer will always be 0. On 21, if you look here and look here, I've got the same values for n and m. And because they're the same, I'm going to use negative 3, and I'm going to use an invisible 1. And so it's negative 3 over 1, which is just negative 3 as my limit. And the rest of the problem should be fairly straightforward. I want to draw your attention to number 23. I think that's a good one. As you're going to infinity for this one, the answer should be with the n and m rule. And if you look at 10n cubed over 6n cubed, n cubed over n cubed is really a form of 1. So because n and m are the same in power, I just keep the coefficients. 10 over 6 equals 5 over 3. Now your answers for the remaining problems, those problem numbers have changed. If you didn't get it in class, it's page 802 and 803, and then it's the same numbers as what you had before. And number 25 is to find the equation of the tangent line for f of x, and they give you this right here. Now remember that if they want the tangent line's equation, then you're going to have to find the derivative, and when you do that, then you can plug in that x value. So to find the tangent line of this, you're going to have to find the slope of the tangent line, and when you use limiting process, f of x plus h minus f of x over h, as h goes to 0, you'll find out that your slope ends up coming out to, using this process, 16x. Now you can plug the negative 2 in, and you'll get a slope of negative 32. Now your last step is to figure out what the function value is. And so we're going to try to come down to y minus y1 equals the slope times x minus x1. Now we already have x1 right up here, but I've got to find y1. So I'm going to take my function, which is really y1. That's what f of negative 2 is. And I plug negative 2 into my original function. And when I do, I get 8 times negative 2 squared minus 7 times negative 2 plus 11. And when I solve that, it's 57. So my xy point, x1, y1, is negative 2 from the top and the 57 from the calculation I just did. So now I have 57 right here as y1. I have x1 right here as 2. Notice it's x minus x1. So that's x minus a negative 2, and that's why that's a positive 2. And there's your final equation. Notice the slope is negative 32, and we got that up here. So your steps are really 1, 2, 3. Number 1, find the slope of the tangent line using the limit of difference quotient. Then plug in your x value to figure out the exact slope at that point. Number 2 is to find the y1 value using your function and plugging in x equals negative 2. And then finally, step 3 is to use point slope form, and that's done. You're finished with the equation. That covers up through number 25. And if you have any other questions, bring them into class. We can cover them then. And good luck on the preparation and on your final exam.